Hey folks, what's up? Another equipment autopsy. This is the HeathKit audio generator model IG-72. I hadn't posted any videos for the autopsies in a while because I wanted to do this next and it wasn't working properly. And it took me a while and the help of a friend of mine to determine what was wrong with it and fix it. And I will show you guys what was wrong with it and what I had to do to fix it. But, so, as I said, this is an audio generator, so it'll put out different frequencies based on what you have the knobs at. You've got a 1, 10, 100, and 1000 X multiplier. Down here you've got your actual cycles, so you can go between 0 and up to 100. And then you got 0 to 10. And this is your dB/volts FS. I'm not sure what the FS is. I guess this might be the strength of the output, if I had to make a guess. And this here, again, I'm not too sure. I think this adjusts the strength of the output on it. And I'll demonstrate that with my multimeter. So I'll just hook that up here. Okay, so looking at this, I'll try and get that to stay there. There's not really any place to put it. So it's good enough, I suppose. You can kind of make that out. So, say I wanted to get 60 hertz out of this, just like, you know, what we get here in Canada and the US on the power grid. So, what I would do is I would go to I would go over here to cycles. I would set this to 60. Now, this is 100% accurate, because I think I need to replace a bunch of resistors and that. It's older stuff, and it's a little bit out of tolerance, but I can still get 60 hertz with a few adjustments. So I put that on 60. I bring this 1 over here to 2. And as you see, that's 60.1, but if I back this off here just a bit, so there's 60 hertz exactly. So that's what we have on our power grid. And in the UK, which is 50 hertz, let's see if I can get that. See if I can get that to 50 exactly. I may not be able to. No, I can't quite get it to rate on 50. Or can I? No, I can't. Like I say, it's a little bit out of tolerance, but you get the idea. I'm not sure what the load button is here. It's got a 600 ohm load, internal or external. And again, I believe this here, I think it's the strength. So if I turn this up, you'll see the RMS volts does come up. And again, I'm not exactly sure what this is supposed to do. If anyone knows, I'd like to know. Just post it in the comments and I'll have a look. So, yeah. But if I wanted to go really high in the frequencies, so let's go to 10x. So look, though, there's 494.3 hertz right there. Then I keep going up, I get into the kilohertz. And you go even higher, go 100x multiplayer. So there's 3 kilohertz, 5 kilohertz, 10 kilohertz, and I take this to 1,000. $40, $50, $60, $80, $90, $100 kilohertz. So this thing can put out a maximum of, well, it probably should be about 110 kilohertz, but that's, oh, that's close enough. And first of all, I'll show you guys the inside of it, but then I'll actually show you what possible use this thing can be used for. You can hook a speaker up to it, and you can hear different frequencies through sound, but I've got another use for it. I've tested it, it already works, and I will show you guys that after I show you what's inside it. So, that's what I'll show you next, the insides. Alright, so here's a look inside it. This is on the top part of it. You've got your multiplier switch there. You've got your actual meter. You've got your, this is just a rheostat, which is that guy there. You got 3 tubes in it. You got a 6x4. We've got a, what is this one? I'll have to pull it out and have a look. Jeez, is it labeled anywheres? I actually don't see a label on this. I could have sworn. Oh, there it is. It's a 6AU6. That's very common. And here we've got a 6CL6. Now these have all been tested and they are good. I did have to replace this when cleaning all the switches on this. I found that this one, the inside, the contact surface was eroded away. It's hard to explain, but it was completely eroded. So I replaced it with the same size one, a 5K kilo ohm switch, and it works great. So you got your main transformer there. This is actually what the problem was. It's a dual output capacitor. It's puts out 240 microfarads at 450 volts DC. One of the outputs was bad. I measured it with my meter. One side said about 35, the other side was overload. So I don't know what its range was, but it wasn't good, and that's why the meter wasn't working. So I didn't have a replacement for this. So what I ended up doing was I actually found I had another aluminum capacitor lying around. Now its microfarad's a little off. It's only about 32 out of 40, but its voltage is still 450 volt, and it's pretty close. So basically what I did is I soldered it in. You can see down there, that's the bottom just beside that bulb. You can see one of the terminals is now empty. That's the shorter one. And because I hooked this one up, now the generator works. So you got your choke there, some other capacitors. You've got that's your 0 to 100 cycle switch. That's your 0 to 10 cycle switch. That's your dB/volts FS switch. Power switch right there. And I don't actually know why there's a light in it. I don't understand why that's there, but it is. So that's basically what's in this one, this generator. So I'll set up and show you guys a use this actually has. Right, so back in 2011 I did a video on a sound card motor controller using a laptop and an audio program to control frequency. So and back then, you know, that was before I started talking in my videos, because there wasn't very good audio and there was just a bunch of other issues. But so basically I'm redoing that now, and I'll go over it better now that I do talk in my videos, and I'll explain to how it's done so anyone else that wants to do it and has this stuff can do it. So you got your audio generator. Your output leads are connected to the amplifier. I just use auxiliary in. This is a 300 watt Fisher amplifier, and the speaker output, which is the black and orange wires, are going to the secondary on this 500 volt amp Hammond transformer. And there's your specs. And if you notice, it actually says HL4E on it. It's like it was built for me. So it's wired to the secondary, and also wired on the secondary is two 100 microfarad 350 volt DC capacitors in series. I find with them on, it helps filter the frequency a little better and makes it more stable and gets rid of the noise and all that. And so on the primary side, so this is the side that would normally be plugged into your wall, and you get 12 or 24 out of here, and this could be wired for 120 or 240, but it's wired for 120, and because the amplifier doesn't put out high voltage, I need to step it up, because this motor here is 120 volts. So the output, the plug for the transformer, is just going to some alligator clips, and that's what I hook up to the motor. I've just got a fan cooling the heatsink, because it does get quite warm. This thing will be drawing over 3 amps from the amplifier. So this is the amps the transformer will be drawn from the amplifier, your AC, and your Hertz. So I'm using the same motor as I did in my original sound card motor controller video. So I just plug it in, line this up, so there you go. That's the motor's standard speed. It's a synchronous motor, so it's a fixed speed of 1785 RPMs. Now if I hook that up to the transformer, so now the motor's hooked up to there, so I will turn this on. I've already got this going. You can see the needle wavering a little bit there. I've got it set for 10 Hertz right now. And I have to control the voltage. I have to gradually bring the voltage up, otherwise the frequency goes crazy. I don't know why. It just seems to be how it works. So this is 10 Hertz, 13.5 volts. And you can see the motor is rotating slowly at 166 RPMs. So I bring that up another notch. That'll bring me up to about 20 Hertz. And you see the voltage does actually come up on its own. And as does the motor's speed. So now we're at 517. Bring it up a little more. you can hear as I bring it up, you can hear the motor's noisy bearings speed up as well. So I'll get it to 60 Hertz, or as close as I can. So there's 60.2 Hertz. And you can see that's just very slightly faster than what it was when I had it plugged into the power bar over there. But what I like about this thing is that I don't have to stop there. So if I want to really overclock this motor, I'm going to bring this cycles down to 10, increase my multiplier by tenfold. Now it's at 115 Hertz. And there's 3,400 RPMs. I can bring my voltage up just a bit. So that's at 10, so that's 10x, that's at 10. I'll bring this back down and put this up to 20. So that'll bring me up to 186 Hertz. So 5,400 RPMs. Let's crank it way up. So this will bring me up to 291. There's 8,100 RPMs. I can go even further. There's going to be a point where the motor starts to slip. It can't keep up with the frequency, and that'll be pretty much as much as it can possibly do. So there's 9,600. You can see what the transformer's drawing out of the amplifier. 3.7 amps. That's 119.4 volts, 383 hertz. I can try to get a little bit more out of it, but it won't be much. So now that's 388 hertz. And I'm pretty much maxed out on that. Now I do have another motor and a fan I'm going to overclock as well. Just to show you guys it will work on different motors. Alright, I'll set up the next motor and go from there. Okay, this is an Autopsy motor out of I think it was an old reel-to-reel that was trashed. And I just took the motor out of it and got rid of the rest of it because it was no good. Okay, so I got this set up for 60 hertz, just to show you what its stock speed is. And this motor is very quiet. I can't even hear that running, and that's running at its normal speed. It is only 44 volts, but there's no load on it, so it's not going to slow down. So it's about 3,400 RPMs. So now I will crank it up. So here's 204 hertz. Now if you listen carefully, you might hear it. So there's 13,600. $13,900, 14,000. That's 125 volts, 300 hertz. Now, the other motor, the first motor I had, didn't benefit from this, but if I remove this here, it's not high voltage. Sometimes you'll get an increase in voltage. I didn't on the first motor, but this one I've already tested, so I'm removing it now, and you see I do get it. But you can hear the transformer buzzing because it's not filtered anymore. But because of the higher voltage, I can push this motor even farther. 15,000. So 158 volts, 319 hertz. And I'm pretty much maxed it out at 309.4 hertz, 158 volts. But that's pretty damn fast for a synchronous motor. It's only rated at 3,400. And it's not hot at all. It does have a run cap to help it, just like the other one did. So, yeah. And I've got one other thing I'm going to run, and that's this here. Good little spin down sound. Yeah, it's very quiet. Alright, well, I've got this weird fan here I've not been able to really run before because it's got some weird specs. It's made by EG&G Rotron. 0.24 amps, 11,600 RPMs, 200 volts, 3 phases, 400 cycles per second. Yeah, what the fuck did this thing come off of? It's pretty cool. It's shaped like a turbine, so it's quite neat. But because I just have 120 volt single phase here, it doesn't. I've tried it. It doesn't really work. But I did a little test with the generator beforehand, and oddly enough, it works. I'm not sure why. Now, I am using, like I say, it's 3-phase, so 1, 2, and 3 for each wire would normally go to each phase on what this was installed on. But so basically, I got power going to one phase, power going to the other phase, and the third phase is getting power through a little run capacitor. It's a multi-cap, 1.5 and 3 UF. I've got it hooked up to the 1.5, and amazingly, it works pretty damn well. So I'll demonstrate that now. The bearings are a little bit noisy, but that just adds to the effect of it. So if I ran this at 60 hertz, so there's 60 hertz, 85 volts. You can see it's not very fast, 1,115 RPMs, and just a gentle breeze coming out of it. So here's 115 hertz. 3230. Here's 186 hertz. You have 5,400 RPMs. Good breeze coming off it now. So here's 291 hertz, 85 volts. And then bump it up again. So here's 400, alright, 406.5 volts, 83 volts. Now I'm just increasing the voltage here. That's 114 volts, 10,000 RPM. So that's as high as I can get it. 152.5 volts, 434.3 hertz. I've maxed out the amplifier. I can't give it any more than that. 2.82 amps, and it's doing fairly. You know, it's within 1,000 RPMs of its rated speed. Now, if it had full 200 volts, I might get that extra 1,000 out of it. But this thing's blowing pretty good. Yeah, so that's pretty good considering it's 3-phase, 200 volts, 400 cycles, and I'm running it on single phase. I had 150 volts, so that's quite impressive. But I would imagine this have come off like a ship of some sort, because I've gotten other stuff, and usually their cycles per second is fairly high. 300 to 500 cycles per second on like military vessels and stuff like that. But yeah. So that's it for the HeathKit audio generator model IG-72. It's a good old piece of equipment. And thanks for watching, everyone.